Welcome to the tutorial of today, the Restart tutorial of today. Today we have two speakers for the tutorial. We have Francesco Matera and Marina Settembre. Now I'm reading the bios and then I leave the floor to the speakers. You have 1 hour and all the questions will be done at the end when I enable the question by stopping the registration because for privacy issues, so all the tutorial will be recorded and then we move to the questions, okay? So the title of the talk is AI Elements in 5G towards 6G Networks. And the two speakers are Francesco Matera, that is currently graduated in Rome, La Sapienza in 1985. And since 1988, he's been a researcher at the Fondazione Ugo Bordoni when he works on telecommunication networks. He is author about more than 150 publications and conference papers and a book in 1996, and is now scientific responsible for FUB in Restart. While Marina Settembre graduated with honors in physics from La Sapienza University of Rome in 1985. He has experience in telecommunication and cybersecurity and has been engaged in various roles, research and innovation, project management, intellectual property within Fondazione Ugo Bordoni, FUB. And yeah, let me say, of course, the bios are much longer, but I think that due to some like technical things, we move directly to the title, to the talk. I'll be sharing the screen. So because due to some technical limitation of Zoom, probably, and I ask the speakers to tell me when it's time to move on with the slides, okay? So let me share the screen. Okay, you should be able to see the screen. So please,
Perfect.
Francesco or Marina, whoever wants to start.
I will start. Thank you, Dario, for your presentation, and good evening to everybody, and thank you for joining us with this tutorial, which is part of the Restart program. And this tutorial is an opportunity to explore how artificial intelligence is becoming an essential enabler in the future network design and operations. And we hope that this session will be a chance to share some ideas on such relevant topics and even learn from each other, because the comparison among us is always an excellent moment to learn something also. And let's go to the first outline, the first slide. Okay, thank you very much. This is the outline of the tutorial. So we began by introducing the growing role of artificial intelligence in 5G and beyond networks by highlighting different approaches to integrate AI across network functions. Next, we provide an overview of key activity in standardization, open source, and industrial initiative, focusing on AI-driven network components and architecture, aiming at enabling multi-domain orchestration. And finally, we share some insight from Restart project, focusing on the selected project in which we are mainly involved, namely ITA NTN, SG-WINET, and NetWin, that really align closely with the topic of this tutorial. In recent years, the complexity of mobile network has grown dramatically, and the complexity calls for automation, and automation calls for artificial intelligence. So artificial is a natural choice to support this need for autonomous network operation also and management, and of course also really optimizing the network performance. And without claiming to be exhaustive, our aim in this topic is just to answer to the questions that we show in the slides before. And so we aim to contribute to this question, how to get from where we are now to the desired land, towards an autonomous and intelligent network. And just before entering into details, just have a look at this quote that has been collected by Charlotte Patrick Research by interviewing a certain number of telco professionals. These quotes really related to automation, but we can replace automation with AI-based automation, or simply artificial intelligence. These quotes in particular help us to understand, to have a chance to test the mood around the problem of including artificial intelligence in network. The first one is artificial intelligence, or automation as you prefer, is a journey. That means that it is not a switch, it's a continuous evolving path. It's difficult, but it's necessary. Another quote is, to understand this mood, is random acts of artificial intelligence in the networks, or random acts of automation. That means that AI is locally already in place, but the big picture, I mean, including a cross-domain picture, is still missing. And another quote is Byzantine and unusable. So many AI systems maybe are too complex to deploy at scale in an effective way. And sometimes we have also to consider that fragmentation, over-specification of the standard can slow down the adoption and can introduce some uncertainty in terms of time of the adoption of AI into the networks. And another quote is heroic action in the past. That means that we need some repeatable intelligence, not just act of heroism. For somebody who can remember in the past, there will be very, very big project. An example was, for example, ONAP for network management. And it was so complex, so big, that we encounter many barriers for practical implementation. And then the last quote is, there is a lot of standards we can choose from. So there are different architectural approaches, different interfaces, and competing AI model. And so we can say that choosing the right path is half of the challenge that we have to be addressed. This is just to understand the mood that is still now in the air. So we can move to the next slides. And the next slide is just a perspective from a field actor. This is the last third annual edition of NVIDIA report on the state of AI adoption in the telco world. And they interview more than 400 professionals. And we can see that the top investment priority for AI is still customer experience optimization. That is at about 44%. And, but network planning and operation, including AI into RAN architecture, is the second most cited investment, around 37%. And we have also to consider that professionals that noted that they are investing in AI, in 6G research and development, and in 5G monetization, in reality, 66% of them confirm that they are investing in deploying AI service for RAN or for connector. So we can say that among the AI service for network infrastructure are really confirmed as a priority use case. And so we can move to the next slide, and we have to see that artificial intelligence is essential for the evolution of the chip, but it cannot stand by itself. It cannot stand alone. In order to have artificial intelligence in the networks, it requires a foundational network architecture and AI elements designed to support artificial intelligence. And that's exactly what 5G provides. For example, in this slide, if you want to move also without considering the animation, maybe it's simpler. Thank you, Dario. And in this slide are shown some key concepts of 5G networks that can be considered as really enabling AI. The first is service-based architecture, where traditional network elements are replaced by network functions that can communicate via standardized API over a shared service bus. And this function can be virtualized or containerized and enable cloud deployment and easy scalability. And programmability is the first step toward intelligence. So service-based architectures enable support also, that is also very important, for real-time data exposure. That is a crucial feature for feeding analytics engine in AI model. So full programmability and also this real-time data exposure. Second point is that the integration in the control plane and in the management plane and in the radio access network of intelligent element. So intelligence is becoming deeply embedded in the network, and we will talk later about these elements. The third key feature is the adoption of a cloud-native infrastructure. So deploying artificial intelligence machine learning model, not only in the core of the network, but also on the edge and in the RAN, that really enables fully programmability, not also programmability, but fully programmability across the different domains. And this ensures that network can adapt in real time also to the varying condition and different service demand. Another key issue is the disaggregation of the RAN, because instead of a monolithic radio, now in the radio access network, the radio is split into modular components, and that can be deployed also upgraded also independently. And we will see how also this RAN disaggregation is very important to habilitate artificial intelligence. And of course, none of the things that we have talked about before will be possible without strong network performance. That means the low latency, high bandwidth are really critical and important also to enable real-time inference, closed loop control. Without this performance, AI the results of the algorithm would arrive maybe too late, and it will be not longer effective. And finally, dynamic network slicing, because we know that slice is a sort of a virtual network customized for a specific purpose, but A-driven dynamic slicing allows that this slice can be created, adapted, optimized in real time. So the network can become, in some sense, we have some context aware also. So if we want to summarize all these things, we can say in 3 words that the 3 pillars that more and more characterize the network evolution towards 3G are fully programmability, AI native and cloud native across all network domains. In the next slide, we will see that what we mean by AI native. To understand what it means, it's helpful to look at this picture that is extracted from an Ericsson white paper that it seems to be really very clear. So if we want to introduce AI in the network, we can do it in different ways. The first is augments or replace one existing AI function that is already existing in a real network. For example, we have a lot of AI already in place in commercial network. I mean, for example, downlink adaptation, MIMO sleep, or something like that. The second way to introduce AI in the network is adding a new AI-driven components not present in the legacy system. For example, energy optimizer or something like that. The third is to add add on top a sort of a control legacy component that can handle in some way the AI in the network. Then we will see in the last part of the tutorial more detail about this. But AI native is where all components use AI in and among each other, like in the right part of this slide. The next slide is something to explain about, maybe we can, this is just an exact of the previous slide, is just a comment of what we have already said. So we can move to the next slide that will be about cloud native. So we can say that as mobile traffic volume growth in the past with the LTE network, for example, the mobile core began migrating to network function virtualization architecture, where network functions were virtualized and provided some software on general purpose hardware instead of specific appliance. And with 5G and beyond, in order to provide a stronger flexibility, there is another revolution towards a containerization instead of virtualization. And containerization, it allows for a more enable a greater service flexibility and agility, and this kind of evolution is really leveraging the advantage of cloud concept. And if we consider that we can extend this approach along the different network domains, this will be really a sort of a cloud native approach. But if we move to the next slides, the 3 pillars that we have discussed before, I mean, fully programmability, AI native design, cloud native infrastructure, that we are considering for the evolution of 5G towards 6G, in the path towards 6G, form the fundamental framework for building a truly intelligent network. But to realize the full exploitation of AI, these pillars must be integrated with intelligent network elements. And in particular, we will consider this specific network elements, that is NWDAF, which is the network data analytic function that represents the intelligent element in the service-based architecture, that means in the control plane, as defined by the 3GPP. And complementing this, always developed by the 3GPP, there is another intelligent element that is in the management plane. And this element is called management data analytics function. And it brings data analytics to the management plane. And on the run side, there is another important network element, intelligent element, that is run intelligent controller, that is being specified by the ORAN Alliance. And this can bring also the programmability and the intelligence, we will see later in a more detailed way, also in the RAN domain. In the next slide, we can see that in order to ensure, it's just a summary of what we have said before. In order to ensure interoperability and consistency across the different deployment, we have different initiatives. So we can see here the 3GPP and ORAN Alliance Nectar element, but there are also other framework that will be discussed later in the tutorial that represent the different initiative also for handling and all these elements. And you can see there are many of them. So one of the problem is it's a sort of sometimes of fragmentation, or sometimes we can talk about an over specification. And of course, we have to do our best to try to avoid this and try to find the right path. And now let's start in the next line to see which is the view of 3GPP, which is the evolution of AI and machine learning approach in the 3GPP. And this is a sort of an evolution. And we have to say that 3GPP started with the introduction of network element, that is NWDAF, Network Data Analytic Function, with release 15, so in 2017, mainly for, not really for related on the with the automation. Automation was at that time the main topic for that time. Until release 16, the focus of 3GPP was mainly on the 5G core, and NWDAF and MDAF was introduced at the time, but the focus was on the connector, and so the kind of data that NWDAF in the core, in the control plane, the service-based architecture, the kind of analytics that NWDAF can handle was essentially related with the load level of the slides. And so, for example, the network data analytics at the time were mainly addressed to policy control function and for quality of service parameter selection, or with the nectar slice selection function for slice selection. But this was at the time of the release 16, the main focus was on the connectors. In the release 17, the adoption of AI extended also to the RAN part. And at the time, 3GPP, there was the problem of overspecification on the AI. So there was not so much effort in standardized AI algorithm or also model. They want to leave this open for different options. And they say that the implementation of algorithm or of the model is really use case dependent. And so 3GPP for the RAN started to investigate 3 specific use cases: energy saving, load balancing, that means offloading user from congested cells, for example, and mobility management to handle, for example, handover, disruption, failure, etc. In release 18, which is the first of 5G advanced, AI extended to the air interface. So 3GPP really investigates about the different level of cooperation between the user equipment and the GNOD B. So the activity of 3GPP was mainly related to this. And for the air interface, 3GPP defined other 3 use cases. That was about beam prediction, channel state information, and user equipment position accuracy. Starting from release 19, that is the second phase of 5G advanced, we are more on exploiting this, going to a normative phase of this use case, and also release 19 also serves as a sort of a bridge towards 6G standardization. And if we look at the next slide, we will see exactly a sort of a summary, just to leave you this for your purpose, where you can see the different use case that the 3GPP has already described, not as a standardized, but as a reference guideline, just for not having a sort of over-specification that can be a sort of a barrier for industry deployment. Then in the next slide, we'll see also a sort of, this is something that can be useful because there are so many documents of 3GPP related to AI adoption in this case. So the idea of this slide is to separate the main, of course, is not an exhaustive list, but related to the element, to the part of the OM, to the part of the RAN, to the part of the air interface. So you have a sort of a reference where you can find all the details for the different part that we have discussed. Now we can see the first of the nectar element in the next slide. It should be, yes, exactly. And this network, this is a network element that is in the service-based architecture. So that means in the control plane. So network data analytic function collects data and provides analytic service to all the other network functions that are connected to the common service bus and also to the management plane. NWDAF can be deployed in a centralized or in a distributed model and can be also not also a global or a slice scope. And NWDAF also had the possibility to handle also some analytics related to the user equipment. So in some respect, network data analytics include some analytics also for the part of the radio access network. And NWDAF can also provide, which kind of analytics it can provide? Statistics, that means provide analytics based on historical data, or prediction for the future. And the interesting thing, as we said at the beginning, is that this analytic, each instance of the NWDAF can be registered in the network reference function, so it can be available for everybody and every other network. And in the next slide, we will see how the reference architecture that 3GPP suggests to support the data collection and how these analytics can be also exposed for the other function. So we have an application function, that is the second block, for example, that receive from, for example, the user equipment, some data report from a sort of a collector of the client via data plane or something like this, and expose this event, this data, to the network analytic function using network analytic function specific interface. Then NWDAF provide some analytics to any other network function or also to network management. And so this is a sort of a reference architecture. And in the next slides, we can see also that in a complementary way with respect to NWDAF, also in the management plan, to the control plane, the management plan, we have a similar architecture. We have a service bus that will be the service bus management architecture, while in the control plane we had the service-based architecture. And we have all the network functions that are typical of the management plane. And among these network functions, NDAF, management data analytic function, is the network element in the management plan that provides management analytics function. And MWDAF can behave as a domain specific, I mean, RAN or connector, or can be defined also across the different domain. Then we can move to the other slide, to the next slides, I can't remember. This is, so we have seen the control plane, in the management plane. Now we are moving to the access network. In the access network, 3GPP has in release 15 introduced the new radio access network, where the G node B is logically split in three entities: the centralized unit dealing with the higher layer protocols, the distributed unit, and the remote radio unit. This disaggregation is really important for both for intelligence and for flexibility, and scalability. So it could really improve the performance of the network. And this is with ORAN, and this is with the 3GPP. And ORAN Alliance build on this disaggregation proposed by the 3GPP, standardized in 3GPP, but extend the level of disaggregation. Because in this disaggregation, the different function developed by the different unit can be different. And 3GPP and ORAN Alliance introduce a different level, a deeper level of disaggregation of the RAN network, introducing new open interface, new and also enhance programmability, because with these interfaces connecting the two units, the flexibility is also improved. And in the next slide, we will see also better which is the architecture of the logical architecture proposed by the ORAN Alliance. I don't know if you can see very well, but because the picture is not so clean, but you can see that the gray line of the interface are exactly the same as in 3GPP. So all the gray line is the same as in 3GPP. The green line that you can see are the new interface that have been introduced by the ORAN Alliance, allowing a different interworking among the centralized unit and distributing unit. And this allows really an improved level of flexibility, also intelligence in the network. This is the typical logical architecture. And in this architecture, there are two network element, intelligent element, the non-real-time RAN intelligent controller that is in the management plan, that is the service and management and can in this part there is also the management of training model for AI and policy analytics or something like that. Then there is the near real-time RIC that you can see in yellow at the in the middle of the feature that is much faster and can perform activity with a closed loop approach. So it's really effective in providing AI intelligence. And finally, in the next slides, we can see basically what I have said before about the RIC, that is the RAN Intelligent Controller introduced by ORAN Alliance, and the characteristics of the two non-real-time and real-time component of the RIC. And there is also another slide, I think, more. And here I think that it can be interesting, just to summarize what we have said, a sort of a comparison among, for the access network of 3GPP and ORAN approach. So while the 3GPP is the primary objective of 3GPP is standardize an interoperable mobile system globally, considering all the specification. O-RAN Alliance is more focusing on open, intelligent, and fully interoperable radio access networks, focused on this. There is a different splitting option between 3GPP and O-RAN, and the splitting option allows and O-RAN as a splitting option that is more deeper respect to 3GPP. This allows the possibility of an improved intelligence in this part. The interface for O-RAN, we have the interface that are typically defined for the radio access network in 3GPP, while Open RAN introduced no new interface, allowing the things that we have said before. And radio access 3GPP, initially 3GPP in the past introduced a sort of intelligent elements also in the radio access network that was called RANDAF. But then when O-RAN Alliance came along, and there are 3GPP was more concentrated on the use on providing a reference guiding for the use cases, for the three that we have seen that we have seen before, for the RAN, and also for the interface. We have seen before 3 use cases for the radio access network, and 3 specific for the air interface, including a different level of support, of collaboration between the user equipment and the GNOD. And in terms of vendor interoperability, O-RAN Alliance is more promotes a multi-vendor interoperability, while the solution of 3GPP is more limited and integrated and vendor specific. And both support cloudification, but modular and cloud a native approach in 3G Alliance enables a sort of as a service and distributed AI for O-RAN Alliance. And now we have made a sort of overview about the network elements, but of course we have to see how these network elements can be handled and managed. And for this purpose, there are different kinds of approach. And I leave the floor to Franco Matera to keep on talking about this kind of stuff. Thank you very much, Dario, for your support again.
Thank you, Marina. And now she illustrated us all the elements regarding artificial intelligence in the network. And now the problem is how can cooperate all these elements, and then how can arrive to a network with a totally automatic network. That means that with no human intervention on the network. So this is so you can go to the other. There are several other organisms that try to obtain a complete platform to organize all the artificial intelligence element. First of all, we have the ETSI group that established 2 groups mainly dedicated to the automation, management, orchestration. The first one is the ANI, and the other one is the Zero Touch Service Management. And we can say that NI was the first one and used an approach that substantially had the intelligence on the top of the legacy system. So it was just a first step, but the most important evolution was the ZSM approach, in which it was defined a way to have a closed loop that permitted to improve the network performance, just varying the parameters that were decided by the statistic, the algorithm, by the artificial intelligence element. And next slide, please. So you can see practically the main topics from this group, and mainly we have two important documents that are the one referred to the reference architecture, and the one that dedicated just to the artificial intelligence elements and the service automation. Just to understand the way to it's working. You can see the next slide. And yeah, we summarize practically the architecture of the ETSI ZSM. It practically is divided in two parts. The one, the lower part dedicated to the management of the physical infrastructure, that means dedicated to the resource of the physical layer. And in particular, we have a system management function that by closed loop defined to improve, to change the parameter that in particular to manage the devices that are in the physical layer in order to obtain the best characteristics that are required for the upper part that is dedicated to the services. So you can see this kind of cooperation in which changing the parameters of the resource and the characteristics of the service, the network try to obtain the best configuration. And the link is obtained by the domain integration. And we have to imagine that in this architecture that you see, there are all the devices that Marina explained. That means the WDAF, especially consider the core network, but also the RIC if you consider different access part. Next slide, please. And other platforms are dedicated to the automation. Another one much important is the Open Network Automation Platform that is ONAP. It is an open scenario that try to have a platform that operate on the device on different network domain, and also in this case try to obtain a closed loop automation. And we have to say that it's a platform that works very well when we consider network domain based on the cloud approach. Conversely, there is some difficulties when you consider system with an existing legacy system. Next slide, please. This is just a schema, very complex of the ONAP architecture. In the last part, in the lower part, you can see different parts dedicated, for instance, for the STM control, the virtual function control, but there is a part with the part with the orange part that is just dedicated to the data connection analytics, that it means just for that is responsive for the intelligence part of the HANA platform. Next slide, please. And here you can see an example that ONAP that operate over a run scheme that is the lower part. So the ONAP part try to cooperate with each element of the run device that Marina explained before, the due part, the root part, and so on. Next slide, please. And another, just to consider another important group that try to work with the artificial intelligence automation is the TM Forum, based on another kind of consideration for the network, that it is the intent-based networking. That means just a network that trying to understand what is the intent of the input, try to obtain the best configuration of the network just to satisfy the requirement from the intent. Next slide, please. And in this picture, I try to understand how to collect the behavior of different network domain. In the left part, you can see, for instance, the case if we consider all the open source, the main part is considered by the run part, that is the run, with the intelligent element, the non real-time RIC, the near real-time RIC. In particular, we can see anche the location of this intelligent part that practically with the platform that try to operate both with the run and with the core. In particular, with the non-real-time RIC that is considered practically inside the ONAP platform, with the intelligent part that is carried out by the orange part that I showed you before, the DCAE element. On the other hand, on the right part, we can see the case in which we consider all the standardization, in particular the part of the core is based by the NWDAF, and conversely for the run part, still we consider the ORAN part, and the cooperation between these two network domains are obtained by the function MDAF that Marina explained you before, that is just in the manager part of the network. Next slide, please. And a very important element that has to consider for the intelligence in the network, it is the introduction of the digital twin. The digital twin is a concept that is much common in different contexts, but in the network is very important because we try to obtain a digital copy of the network, because in such a copy, practically we can make a lot of investigation that is not possible on a real network. So it means that this network that practically try to reproduce perfectly the real network, and so in such a network we can see the data that is receiving from the reality, how to can change the behavior of the network, and in particular how can make variation in the network in order to improve the performance without working on the real network. So it's clear that the digital twin is mainly based also in intelligent element, because try to understand what happened outside the network and inside and in the network, and try to give the solution to improve the network performance. In particular, we can see different possibility of the digital twin, that is the capacity to scale according to the network evolution, realism and accuracy, integration. Next slide, please. And now I want to give you some very short hints for the Restart project, because in Restart practically all the Restart project treat with artificial intelligence. And we work in 3 different Restart projects that has NetWin, 6G1, 8, and 10. And in all the 3 projects, practically we have a work dedicated to the artificial intelligence. Now we will see. And I also wanted to underline 2 important grand challenges in Restart that are dedicated just to the artificial intelligence, to the management of the network. It is the Grand Challenge 10 and Grand Challenge 12. Next slide, please. This is the other challenge. Okay, for instance, a NetWin project is one of the projects that is mainly dedicated to the artificial intelligence, in particular artificial intelligence, both to see how the artificial intelligence can help the network and how the network can help the artificial intelligence. That means how can improve the elements of artificial network in different conditions. And we can see that this scheme practically takes into account all the elements that are both in the core part and also in the access part. And in particular, with the red circle, we can see all the devices that Marina explained before, NWDAF, the the RIC non-real time and near real time as far as the RAN part is concerned. And we also add an element that is not standardized, but can be from interest towards the RAN-DAF. And all the automation in the network is performed by the means of the MDAF that is in the managed part of the network. It's also important to underline that in this scheme, that is a scheme that was considered by Network Project, we also consider the introduction of the digital network digital twin. That means that there are specific functions inside the network that try to emulate the real network. Next slide, please. So, as I told you, that we work with a lot of artificial intelligence elements. First of all, the semantic communication. That is, semantic communication is based on the fact that we try not to transmit bit, but contents. The main concept of the information, it means that I can save a lot of bandwidth just to obtain this possibility. And just for this consideration, the network is important for AI because I have to make the infrastructure that allow us to have the best performance in this term. And another important work carried out inside this project, the digital twin, try to understand how to obtain the best digital twin, and also how to obtain the best copy, we can say, of each segment network. Next slide, please. Some consideration for the net winner is considered for WWF because now we can see that one of the most critical part of the intelligence of the network. So we have to see how to work with this, how can distribute the components of this function, and how to solve several problems, considering also the privacy and the security. And then the project and twin consider different use cases where the artificial intelligence was much relevant. In particular, for instance, the mobile intelligent robots. That means during the movement, they try to understand what is the best path they can do without accident, and also for to obtain the best frequency allocation for the communication. Another one regarding the drone, in particular the UAV element, in particular with the processing that can be obtained at board of the device, also with the communication with the ground elements, especially in some cases, like for instance, the smart agriculture. Another topic is the virtual graphic assistant. Next slide, please. Just very short elements for the 6G one. The 6G one is mainly dedicated to the implementation of the network for V2X for the vehicles, and there are several elements of the target network, but the network is based on the oral architecture, and therefore all the intelligent part, they have to decide practically the correct behavior of the cards is obtained inside the intelligent part of the oral, and that means with the RIC element. Next slide, please. And then we can consider the project ITNTN dedicated to the non-terrestrial network in particular. In this case, we have to understand where to locate the artificial intelligence elements in each device, because practically we can have a different possibility according if a device, like for instance satellite, a drone, works like genome bit, also like a core element. So the question is where we locate the elements that we show you for the core, for the RAN, inside one of the non-terrestrial elements. And just consider this for the difficulties, we consider a particular scheme. Next slide, please. because obviously we can have different elements and problems that can obtained for a non-terrestrial network. And in particular, we have seen that the artificial intelligence in this case can operate in particular for the personal evaluation, in particular for resource optimization. Another problem very critical for non-terrestrial network is the handover, in particular when you consider the satellite in low orbit. And so the decision for the best improvement to improve the performance, because the handover can introduce a lot of outtime. And then the project work in particular with the characteristic of the optical links in the free space, in particular with the intelligence adopted to improve the choice of the best optical path to be obtained. And in particular, there was also a study considering the evolution of the network towards a cloud native with a Teraflow orchestrator. And then also the importance of the non-terrestrial network to help the artificial intelligence. That means with the drone, for instance, we can increase the number of the edge device just to have an intelligence that is very close to the element that we are interested. Obviously, in this case, we also to consider the limits of the non-terrestrial elements, especially in terms of the energy, in particular the energy need. It means that we have to consider the energy saving aspect. Next slide, please. So we also consider an infrastructure that try to take into account all the elements of the non-terrestrial network, also for the terrestrial network. That means the coexistence of different networks. And in this case, we, according to the schema that we have seen, for instance, from 3GPP, for this kind of architecture, we prefer to distinguish, we try to distinguish the plane for the management, also for the artificial intelligence that help the management in two layers. That okay, we started with the base of the 5G network that is based on the service-based architecture, but especially for the part that is close to the infrastructure, in particular the part that regards the management of the devices, there is the possibility to have a faster knowledge of the network by means of artificial intelligent elements, just to control in a faster way the network, in particular to control the optical part. So you consider that all the blue part you see in the transparency can be mainly dedicated to the manager of the optical part, that means the optical fibers in the core infrastructure, and the free space optics for the access, for the non-terrestrial access. Next slide, please. Okay, this is has been an overview regarding the artificial intelligence. Some last consideration regarding the importance of these characteristics. Obviously, the artificial intelligence is the future, but we also consider the cost for the artificial intelligence, the problem of the data for training, because the algorithm require a training process, and a question is the investment, also the return of the investment, considering technology that are quite expensive. For instance, just to consider that the necessity of very powerful computation. Next slide, please. This is another important, the use of the data set. So the fact that we don't have sometimes at disposal a lot of data, in this moment we have a lot of work is made for the implementation of the simulation platform, in particular to that are in the same consideration for the digital twin. In particular, it's very important at the moment the emulation, the simulation based, for instance, on the code NS3, especially for the run simulation. In fact, inside the 6G one, a platform based on NS3 with NVIDIA for the physical part, NS3 for the upper part of the network, was implemented. Next slide, please. To go just to the conclusion. There is a topic very important, but there is no time to discuss, and the use of the generative artificial intelligence in 5G and beyond. It means that it is a different approach. That is not the use of artificial intelligence to improve the performance of the network. That means that artificial intelligence elements that work in a real network or that in a simulation of the network. It means that we try to understand the behavior of the network just by generating practically a model of the network. So without considering just in details the elements of the network, we try to understand what is the behavior and the particular data can be given by the network. Okay, just going to the conclusion, because the last one. And in conclusion, we can say that we have seen practically all the elements that regard the use of the artificial intelligence in the network. We have seen different standardization body with different solutions for the elements. We have seen how all these elements can cooperate with each other, and just to obtain a total behavior of the network going towards a complete automation of the network. In particular, we have seen in particular the ZSM, the importance of the evolution towards the cloud native, towards open solution, and the important role that will be the digital twin in the network. Concluded the aspect that we have seen, for instance, for restart is the fact that there are a lot of work considering with the artificial intelligence, with the several experimentation, and in my comment is that most of the work are dedicated to the artificial intelligence in the access and the edge part, less with in the core, because obviously there is much difficult, and also an interest to evolve towards a cloud approach, also the core network, because the containers are much easier to manage with orchestration, like for instance Kubernetes. Just to conclude this consideration. Thank you very much for your attention.